So matrices, there's our three that we'll kind of start with and talk about. Once you get those written down, we're going to put them in the calculator. And I believe there's a button on there somewhere that says matrix. Find it? Anybody find it yet?
Yes.
Yeah, above x to the negative 1. On the left, toward the top. So second matrix. Okay. Names, math, edit. You know what we want to do first if we want to put one in? We want to edit one. We want to change one. So names is when we want to use them. We'll do that later. Math, scroll over. That's all some of the crazy stuff that you can do with matrices. I don't even know that we'll use any of those. So that's some of the weird stuff that you can do in matrices. I don't know that we'll ever use the math menu. So let's go over to edit, and let's edit A. And do you know if A is 3 by 2 or 2 by 3?
3 by 2.
Let's see, it's always rows by columns. So that'd be 3 by 2. The good news is, especially if you have a calculator, if you forget which way it goes and you think, oh yeah, that's a 2 by 3, and you put in 2 by 3, well, you learn right away that, whoops, I guess that's a 2 by 3, and I've got a 3 by 2. So you're not going to mess up the dimensions, because if you do, you immediately realize it and then go fix it. Put in each piece. The only potential trick here is on that last one. Until you hit enter or move to a different entry, that bottom right element of that matrix is still 0. I've typed in 3, but I haven't hit enter or moved around yet. So this is one little error spot where if you're trying to go fast, you type 3 and then you exit, you haven't changed, right? You think it's 3, but the calculator doesn't know it's 3 yet. So either hit enter or just arrow to a different sort of element or cell, and now we're good. And do take the extra 3 seconds to make sure that you typed everything in correctly, because the calculator is not going to mess up the math. The only problem is, or the only errors really happen if you type something in wrong. So do take the extra second to make sure it's correct. All right. There's not a way to back up in the menu. You just have to exit and then go back in to put in B. So second quit, and then do the whole process over again. Matrix, edit. And by the way, now it knows that matrix A was a 3 by 2. But we want to edit matrix B. Even if you don't know rows and columns, that's a 2 by 2. Type in all the elements. Double check it, make sure it's right. And then exit and go do matrix C. Second quit, second matrix. Again, it's pretty quick, it's pretty easy, but you've got to double check to make sure that your elements are in there correctly. All right, second quit. Now they're in the calculator. Let me just. The button is second matrix, but there's not really. Once you find, it's not one of those hidden buttons, right? You don't have to know where it is. It's on the calculator. So as soon as you find the matrix button, you're fine. Dimensions. It's rows by columns. But again, if you're not sure, you type it into the calculator and see if you're right. And if you got it backwards, well, then fix it. All right, let's do some basic operations with matrices. This will, again, everything's with calculator, so this isn't really, it's just about knowing which buttons to push. Let's do B plus C. I guess maybe an error would be to just say B plus C, but that's not the right B and C, right? Those are like numbers B and C. You want matrix B and C. So go to matrix. And now we don't want to edit B or C. We want to use them. So we'll just use the names and go down to B and hit enter. And then you know it's a matrix because it has the brackets around it. Plus, and then go get matrix C. So the B plus C, press enter, and there's B plus C. Adding matrices is easy even without a calculator because you just sort of add by position. 4 plus 2 is 6. Upper left plus upper left gives upper left. Top right plus top right gives top right. So adding is easy. The calculator is going to do it all anyway. Multiplying is a little bit trickier, but the calculator does it. Let's let the calculator do it, and then we'll talk about what our answer looks like. So let's do A times C. Matrix A. And then you can either hit the times button, or you can just go to matrix C and just write it like that, because two numbers next to each other means multiply. So matrix C. And there's matrix A times matrix C. Okay, multiplying is a little bit weirder when it comes to matrices. So a little bit of work out to the side here. Your calculator is going to do it all, but I need you to understand what's going to happen on the next one. Matrix A is 3 by 2. Matrix C is a 2 by 2. So clearly multiplication can't work like addition. You can't just do top left times top left and top right times top right, because these aren't the same size. In fact, if you tried to add A plus C, you'd get an error because you can't do it. They're not the right size to do it. But you can multiply them, because if the insides match, if they're equal, then it works. If the inside dimensions are equal, then you can multiply. And then the outside dimensions is your answer matrix. So that's sort of as deep as we'll go with it. If the inside numbers match, you can multiply, and that means your outside numbers will tell you the dimensions of your answer. Let's try C times A. Thank you. So in the calculator, C times A. And I get an error message, dim mismatch. Any guess what dim stands for after our discussion 30 seconds ago? Dimensions. The dimensions don't match. And they don't match, so C times A is not possible, because C is 2 by 2 and A is a 3 by 2. So those inside dimensions don't match. That's a dimension mismatch. So all that to say is there are questions on the homework and on the tests that don't work. And so you don't really have to know why they don't work. just understand that there's some that don't work, and if you type it in and it doesn't give you an answer, then you just say not possible. You didn't do anything wrong other than ask your calculator to do something that doesn't work. All right, next let's find B inverse. Well, you find it just like you think you'd find it. Go get matrix B, and then hit the inverse button, or the x to the negative 1 button. So B to the negative 1, like usually to the negative 1 just means flip it over, but it has it's a little bit more complicated for matrices. We're not worried about where these numbers come from. And I don't really like those, so I'm going to change those to fractions. So you can do the math frac thing. Math, and then frac, and it'll change all of them to fractions. And you have a nice looking fraction matrix there. Three-tenths, one-tenth, one-fifth, two-fifths. Sounds like the start of a Dr. Seuss. One-fifth, two-fifth, red-fifth, blue-fifth. So where that comes from, again, it's more complicated than we want to worry about. We just let the calculator do the work and don't really worry about it. Last one, then we'll do something else. 3 times C. Again, you could just go to the calculator, but 3C distributes a 3 to everybody in matrix C. So it might even be faster to do 3C without the calculator. Because all it does is distribute the 3 to each element. Again, probably faster without a calculator than with a calculator. All right, so that's like the basic stuff of matrices. Now let's step it up a little bit and let's solve some equations. Even here, there's sort of 2 separate ways to do this. One of them's, I think, easy. So let's say we have this matrix equation. Copy that whole thing down. And then we'll solve for x and y. Let's see. So there's x. And I'm adding matrices. So adding I do like by position. So I'm looking at the top left. So most of the other numbers, or at least none of the other numbers I should say, matter. I just want the top left stuff. So let's write an equation using the top left stuff. Now be careful. What would the equation be? X plus, and that's where I'd be careful. Why 2, Brandon? That 2 out front. That's like the only thing that people mess up. They get so focused in on, okay, top left, x plus 1 equals 7. Like, oh, wait a minute, there's a 2 out front. So x plus 2 equals 7. So x equals 5. All right, solving for y, we'll use the bottom right pieces. But again, the same thing, don't forget about that 2 out there. So 3 plus 2y equals 11. 2y equals 8. Y equals 4. All right, pretty simple when they're like that. Just be careful. Make sure you're paying attention for the numbers that are out front. Okay, now for the most useful thing we do in matrices. Using matrices to solve a system. A system of equations. You've done this before, but do you remember what a system of equations is? Let me back up. You've done this before, just not using matrices. You've done solving a system of equations. You've not done it with matrices. So do you remember what solving a system of equations means? It's okay if not, because you're going to recognize it when I show the first example problem here. Let's say x plus y equals 2. And 2x minus y equals 15. So that's a system because there's more than one equation. Solve basically means find their intersection. Like, what point do they have in common? So the back way up, the first way you did this was to graph them and just look at your graph and see where they intersected. Then you did substitution, right? You would say y equals 2 minus x, and then in place of y, put 2 minus x. Does that sound familiar to three of you? And then the last method you did was elimination or combination, or like you would add the two equations, because the y's would cancel each other out, and you'd end up with 3x equals 13. And do it that way. Those are all easy and fine. Matrices become helpful when you get a whole lot of equations. So let's look at how to do it with a 2x2, even though there might be better methods with two equations. But later, matrices are the way to go. So I'm going to rewrite this system as one matrix equation. And the first thing I'll do is just grab the coefficients. Not the x's and y's, just their coefficients. And put them in the same sort of order. So 1, 1, 2, negative 1. Then we're going to list the variables. We'll list them in a column format, x and y. And then we'll put our answers, 2 and 15. Now, because of how matrix multiplication works, which we don't really know, this is the same thing as these two equations. So I took two equations and turned it into one matrix equation. I mean, obviously more complicated, but it went from two equations to one equation. In fact, we could sort of model this as A times X equals B, where A and X and B are matrices rather than just numbers or variables. Right, I'd like to get X by itself. What would you normally do to get X by itself in this equation? Divide by A. I like that answer. The trouble is you can't divide with matrices. Like, matrices just don't divide. So let me throw this at you. If you had 5x equals 13, normally most of you would probably divide by 5, as would I. But if I told you you couldn't divide, what could you do to get x by itself?
Multiply by a fifth.
Multiply by a fifth. Another way to write a fifth would be 5 to the negative 1. Not that you would ever write it that way, but you could. And then you'd have your answer. Now that's a little bit weird, like nobody would do that because you don't need to. But over here, you're not allowed to divide, so you have to multiply. And what you'll multiply by is a to the negative 1. And just like 5 and 1/5 sort of cancel each other out, a inverse and a cancel each other out, and you're left with x equals a inverse times b. So let's go to the calculator and do that, although I need to change a and b now because that's not what is in there. So matrix, I need to edit matrix A, and I need to change it to a 2 by 2. 1, 1, 2, negative 1. Alright, then let's go change matrix B. Edit matrix B. It's a column matrix. So whether that's a 1 by 2 or a 2 by 1, you don't even have to think about, because if you get it wrong, you do it the other way. It's a 2 by 1. 2 and 15. Now we're ready to do A inverse times B. So go get matrix A, and then do the inverse thing. And then times, go get matrix B. Inverse times B. And there's our answers, sort of. Let's change those to a fraction though. So the math frac button works with matrices as well. So 17 thirds and negative 11 thirds. Okay, that's not quite how I want your answer, because way back when this problem started as just like a system of equations where I want x and y. All you do is tell me that's the answer. You haven't told me, I mean I know, but you haven't told me who's x and who's y. So your answer is x equals 17 thirds, y equals negative 11 thirds. Or you could write it as an ordered pair, because we recognize that as x comma y. So super easy to do, but make sure you answer as telling me who's x and who's y. And you can explicitly tell me who's x and who's y, or you can write it as an ordered pair. Now, we showed a whole lot more work than I'm expecting you to show. Let's do one more, and I'll show you what I expect you to, or what I want to see. In fact, let's do one that's a little bit harder. 2x plus y equals 0. Negative 4x minus y minus 3z equals 1. And then 3x plus y plus 2z equals 2. So this is one where matrices are way better than the other methods, because with 3 variables, solving this by hand would be a pain. But solving it with a matrix is going to be pretty easy, because I'm just going to write down my coefficients. What's my z coefficient in that first equation? 0. Okay, so you can't just like leave it blank. 0z would wipe it out, and so that there's a 0 there. Sometimes people forget to include the signs, like they look at that coefficient of y and they're like, oh, the coefficient's 1. Like, no, it's -1. So make sure you get the signs in there as well. And then now you're ready to go to the calculator. So I don't need to see all the x's and a's and inverses stuff. Second matrix, edit matrix A into a 3x3. And always double check your matrix. Right? The calculator's not going to mess anything up. It's the garbage in, garbage out problem. If you give it a mistake, it's going to give you a mistake coming out. So take the extra second to make sure everything is right. And go edit matrix B. Oops. Edit B. 3x1. 0, 1, 2. Again, don't get in too much of a rush. Make sure that it's in there correctly. And you could go in and type A inverse times B, but you could also just go like scroll up, and you've already typed it in once, so you can just go get it. And it will do it again with the new A and the new B. And so there's my X, Y, and Z. And I'm just going to write that as an ordered triple this time. And there's my answer. All right, last thing of note, weird things can happen. So weird, it gets its own little note here. Weird things. If you get an error, then one of two things has happened. Let's see if you can figure out what one of these things is. If I want to get it won't be that error. It won't be the dimension mismatch thing. I think it would say singular matrix, I think is the name of the error. But you don't really know what that means. So looking at this problem, if you tried to find the intersection of 2x plus y equals 3 and 4x plus 2y equals 6, do you notice something about those two? What's that, Brandon? That's the same thing, right? If I divided the second one by 2, they'd be the same thing. So that would be the same line. So it's kind of weird. It's like, where do they intersect? It's like, well, they intersect everywhere because it's the same line. And so the answer is all points on the line. Be careful. Don't stop with all points, because it's not all points everywhere. It's just all points on the line because it's the same line. So you kind of have to recognize that. Do you remember the other weird case from solving equations? There's sort of two weird cases. Like the normal case, they intersect. Okay, find the intersection. One of the weird cases is it's exactly the same line, so they're like, it's everywhere. Do you remember what the other weird case is when you're trying to find the intersection of two lines?
When they never intersect, so they're parallel.
When they never intersect, so they're parallel. Here's what that might look like. Negative 3x plus y equals 5. 9x minus 3y equals 7. So those aren't multiples of each other. But if you solve for y, y equals 3x plus 5 for that first one. Solve for y on the second one. Negative 3y equals negative 9x plus 7. And then if we divide everybody by negative 3, we get 3x minus 7/3. And what would you say about those two lines?
Same slope.
They're the same slope. So they're parallel. And that means they don't have any intersections. So you probably, let me finish this and I'll answer your question. You probably, some people, if they're really paying attention, they might catch one, especially if it's like only a multiple of 2. Like, wait a minute, that's the same line. I'm not typing all that in. That's the same line. Sometimes you're like, I don't know what's going on there. You put it in the calculator. You get this singular matrix error, and then you got to figure out which case it is. Did that answer your question, Toby? All right, I need to give you the worksheet.